This video is a continuation on how to graph if we're given an equation in vertex form. So if we go ahead and take a look at our next example, it says to graph this. So to graph, you can go ahead and pick whatever numbers you want, plug them in, and if you don't know what to do, keep plugging in more numbers until you see the shape of the graph. However, being that I know when I look at this, that the highest exponent's a 2, I know this is going to be a parabola. And so I know by looking at this is in vertex form that I'm going to take the opposite of the number that's in the parentheses, so 1, and then -4. That's going to be my vertex point. That's going to be the very top or the very bottom of the graph. So 1, -4. Now, being that the number in the front is not negative, we know the graph is going to go up. So when I plug numbers in, this graph should open up. If it doesn't, then I can catch my mistake by knowing my transformations. I know that the graph should move to the right 1, which I did when I graphed that, and it went down 4, and it shouldn't be stretched, it shouldn't be shrunk, it should look just like the parent function. Okay, so now I'm going to go ahead and pick whatever number I want. So I'm going to draw this line in. It's dashed. It's not really there. Whatever point's on this side, I'm going to reflect onto the other side. So I could pick whatever number I want over here or whatever number I want here. So I'm going to go ahead and plug in 2. So I'm going to pick 2. You could put the 2 wherever you want. I'm putting it here because 2 comes after 1. It's up to you, though. The order of this doesn't matter. So then I'm going to take my equation, x minus 1 quantity squared minus 4, and I'm going to go ahead and plug in the number I chose, 2. So you can pick whatever you want. 2 minus 1 is 1, 1 squared is 1, and then 1 minus 4 is -3. So now I'm going to go ahead and graph the point 2, -3, and notice the graph is going to go up like we said it should because of the leading coefficient, the a value in the front. So now if I reflect this point is 1 away, there's going to be 1 away on this side. So if I want to check that number is 0, and if I plug in 0, you can see that 0 minus 1 is -1, and -1 squared is still 1. So you get the same answer here as well. So that's the cool thing and why I put my vertex in the middle, because these should always match on the other side. So now I'm going to go ahead and plug in 3. So I'm going to go ahead and take my function, quantity of x minus 1 squared minus 4, and I'm going to go ahead and use 3. You don't have to, that's just the number I picked. So 3 minus 1 is 2, 2 squared is 4, 4 minus 4 is 0. So I'm going to go ahead and graph the point 3, 0. And so since this is 2 away from the line, I'm going to have another point 2 away on the other side. So if I don't know what it looks like, I add more points. So this point right here is at -1, 0. So these should match if you're structuring your table like I am. Then when we connect them, it should make a U-shaped graph like that. So then it says identify the vertex. So again, the vertex in this case is the very bottom of the graph. It's the minimum. So it's at 1, -4. And then the axis of symmetry is the equation of this line, this vertical line right here. And it's always x equals whatever the vertex x value is. So it's going to be x equals 1. And it's the very bottom of the graph, so it's the minimum. And then the x-intercept is where the graph crosses the x-axis. So it crosses here at -1, 0, and it crosses here at 3, 0. And then the y-intercept, where the graph crosses the y-axis, is right here at 0, -3. So now I want to do a problem. Oh, actually, before we do, let's go ahead and just check with the 1-3-5 rule, because what if we did our math incorrectly? So you don't want to graph using this. You want to check. So it says you take a, which is the number in front. There isn't, so it's like a 1. And then you multiply 1 to the odd numbers. 1, 3, 5, 7, right? All the odd numbers. And when you multiply 1 to these numbers, it doesn't do anything. It stays the same. So go ahead and take your pencil and point to your vertex, and you're always going to go over 1, and since these are positive, you're going to go up 1. Okay, now go over 1, and now go up 3. Now go over 1, and go up 5. 1, 2, 3, 4, 5. So if I wanted another point, this is like even better. It should go like that. And then if there's 1 here that's 3 away, there should be 1 here. So by using this, now I just gained another point that looks even better. Okay, so that's the 1, 3, 5 rule. All right, so now we're going to do another problem, and notice there is no graph. And it wants us to find the y-intercept and the x-intercept without looking at a graph. And this would also be used if you looked at your graph and you couldn't tell where it crossed. So maybe it crossed like in the middle here and you couldn't tell what that was. This is the math work you would show to find the x-intercept and the y-intercept if you couldn't look at the graph and identify it. So since this problem here does not give us a graph, we're going to have to do it algebraically. So to find the y-intercept, remember f of x is the same thing as y, it's just the output label. So y equals 2x squared minus 5x minus 3 is our function. And it says to find the y-intercept. So at the beginning of our notes, we wrote down to find the y-intercept, you're going to plug in 0 for the x and then evaluate. So this is how I think of it. If I want to find the y-intercept, I need to leave the y in the problem. So that's how I remember if I'm finding the y, I need to leave the y there, and then I'm going to plug in 0 for the other variable. So then we do our order of operations. 0 squared is 0, times 2, that's 0. And then negative 5 times 0 is 0. And then we get 0 minus 3, that's just negative 3. So to find this, we plugged in 0 for all the x's, and we get the ordered pair. Remember, x goes first and then y. The x value we plugged in was 0, and we get out a negative 3. So that is our x-intercept. Now we're going to do the that was our y-intercept. Now we're going to do the x-intercept. So we take our function, and we say to ourselves, we want to find the x-intercept. We want to know what x is. So we're not going to put anything in for x. That's how I know I'm going to plug in the 0 here. So when you find x and y-intercepts, yes, you're always plugging in a 0 because for something to land on the x-axis, it has to have a y value of 0. And vice versa for the y-intercept. So that's why we're always using 0 and not 5. So we plugged in 0 for the y. Now, to solve this problem, this one's not as easy as this one. This was just an evaluation, or we just evaluated here. But this one, when an equation equals 0, to find out what this variable is, we have to solve the equation using the methods that we learned earlier in this chapter. So remember, you can use factoring if it's possible. Remember, not all problems can be factored. We could do completing the square method. You could use quadratic formula. So you need to pick one of these methods that we learned. So if you have forgotten, look through your beginning of chapter 9 notes and use one of these methods. So I'm going to go ahead and use the quadratic formula. So to use the quadratic formula to find out what x is in this problem, it's negative b plus or minus b squared minus 4ac all over 2a. So this is our quadratic formula, and we use it when the equation equals 0, and we want to know what x is that makes the equation 0. So we would have, this is a, this is b, and this is c. So negative b plus or minus b squared minus 4ac, all divided by 2a. So now the opposite of negative 5 is positive 5. And then negative 5 squared is 25. And then negative 4 times 2 times negative 3, a negative and a negative times a negative is a positive, and we would get 24 here. And then 25 plus 24 is 49. And then remember, when we get it down to 3 numbers, we always start with the radical. The square root of 49 is 7. And then we would have 5 plus 7 divided by 4 as a solution, and 5 minus 7 divided by 4 would get us a solution. So we'd have 12 over 4, which is 3. So one of our x-intercepts is 3, 0. And then 5 minus 7 is negative 2, and negative 2/4 is just negative 1/2. So we have our x-intercepts. Now remember, whatever the exponent is, the highest exponent tells you at most how many x-intercepts you can have. So what we just found here was, if we were asked to graph this, we just found where the function crosses the y and the x-axis. So this equation right here, it's not in vertex form, so we can't just look at it and know the vertex, but we know it crosses down here on the y-axis. That's what we found here. And then we know it crosses at 3, 0. And then we know it crosses at negative 1/2, 0. So here. Okay, we know the graph goes up because it's positive. So I don't know, maybe it looks something like this. But that's what we just found, those 3 points, using algebra.